Good afternoon, everyone. Welcome all, and thank you for joining us today in the fourth in a series of 5 lunchtime webinars to be hosted by Simera. Before we get started, just a few housekeeping points. The session will be recorded and we will notify you when it will be made available on the Simera YouTube channel. Also, during the session, please list any questions you have in the chat box. We'll try to address these in the Q&A session or even before if possible. I'm Morris Cunier, and I will today cover in brief a question that is regularly put to us. Why and when do my company need NX? But before we get to that, I just want to draw your attention to the previous webinars that we've completed. First off, who needs PLM and why? How do you scale your PLM capability, and push versus pull workflows in PLM? And you can view those recordings on our YouTube channel called Simera PLM. And then the next webinar session will be on the Thursday, the 19th of May on SimCenter, digitally predicting the future. So today's webinar will focus on understanding the challenges people face with product development. And also there needs to be a rethink on product development in terms of on digitalization and not just digitization. Why Siemens NX is an industry-leading solution to support development. Then the different pricing options available in NX, and this is quite important because it stands out from competitive vendors. And then I'll do a quick demonstration within the additive manufacturing environment, showing some of the unique capabilities within NX. But let us start by reframing the challenges with product development. So companies need to rethink product development. Companies need to create lower cost products with new performance in even shorter timescales. Companies need to have a faster bidding process. They also need to reduce change orders by understanding performance during the initial design phases and reducing the number of physical prototypes. Then companies need to make fast, accurate decisions. This requires companies to manage risk, handle complexity, and document compliance throughout the engineering process. Companies need to get the products right to the market first time. Companies want to cut waste and reduce warranty costs. So the ability to find and reuse existing parts boosts predictability, it reduces risk, cost, time, and errors. Companies need to be able to collaborate. Companies want to be able to do easier business. This requires effective work with partners using the same tool, NX, or any other engineering solution. And then companies need to take product development from concept through to manufacturing. Companies want to cut development costs and engineering change orders. They want to ensure quality throughout the product development process. So does any of these insights resonate with your company's needs? But first, let's have a look what is the impact of these challenges on product development. That is, what are these problems doing to our business? So about 40% of engineering person hours, less than 40% of engineering person hours adds value. 85% of product information lacks product structure. 35% of companies continue to see engineering changes until the release of that product. 166 days on average spent building and testing physical prototypes. 30% of time is spent searching for information to support decision making. 1 in 3 companies have problems predicting product performance. 27% of executives say lack of speed is the biggest obstacle to innovation. 95% of new product introductions fail. Manufacturing is disconnected to the design group. That's quite common. And then 60% of CEOs seek better information for product decision. So if these challenges and bottlenecks sound familiar to you, you are still struggling with them. What is the solution then, and what is the way forward? Now, this might sound a bit cliche, but digitalization changes everything. Digitalization changes all areas of life, the way we stay informed, the way we travel, the way we buy things and the way we manufacture products. And it's also changing business models. The pace of innovation and the ability to disrupt are becoming key success factors in product development. So digital Darwinism is a significant threat to manufacturers in their transformation to a digital enterprise. Technology and society are evolving at a pace that is simply too difficult for many organizations to keep up with. In fact, according to some predictions, 40% of the Fortune 500 are expected to no longer exist within 10 years if they do not evolve soon. More than 50% of companies that attempt to move to a digital model fail. And the primary reasons that companies that try to move to digital fail is that they are not looking at it across the business. They are focusing on siloed digital upgrades. The big benefit comes when you look at the entire process to create a digitalization strategy and remove the weakest links first. So capturing the full potential of digitalization requires company-wide transformation and its top-down commitment and leadership. So within its accelerator portfolio, which includes NX, Siemens has developed digitalization solutions that addresses these challenges. So let us have an overview look at NX. So there are many reasons why people use NX, but let's just have a look at a few. So NX is a single platform that contains all of the tools to break down the barriers between engineering disciplines. NX platform allows an enterprise to complete a complete solution that takes advantage of the data without having to remaster the data in another system. Thus, one of the biggest reasons people use NX is to remove barriers between engineering domains. NX uses Parasolid, which is the leading modeling kernel. So Parasolid is a production-proven geometric modeling kernel used by over 4 million end users in the world. NX allows for the seamless integration of wireframe, surface, solid, and facet modeling techniques. So Convergent Modeling technology from Siemens allow users to work directly with scanned data, eliminating the need for reverse engineering. So this technology allows users to quickly optimize and prepare parts for 3D printing. Thus, NX is not just an advanced CAD solution, it's a technology platform. This technology platform helps to remove barriers to innovation through the following. NX is built on the most modern architecture of any major CAD, CAM, and CAE solution. Deployability. With NX, you do not have to wait to take advantage of the latest advancements in CAD. Data preservation is a hallmark of NX. NX will never force you to leave your data behind and move on to the next release. Open technology is a realistic approach to solving engineering and design problems. Siemens PLM does supply a complete suite of software to address the needs of the enterprise. However, Siemens realized that customers want to bring in solutions from other software vendors. So when do you need NX? Well, companies need NX when they are involved with concept design, product design, require design tools to edit designs, transform their manufacturing data from 2D drawings to 3D models with model-based definition, and need to integrate, automate, and validate processes and engineering data. So let's look at concept design. There you've got NX Realize Shape, which makes it easy to develop complex surfaces transitions without making compromises in CAD. So you can develop complex shapes quickly with integrated freeform and subdivision modeling. With NX Draw Shape, it is an add-on module for freehand drawing of wireframe shapes on bodies. With NX Topology Optimizer, it's an add-on module to optimize geometry driven by functional requirements. So the core is within core capabilities of NX is within product design, and this includes convergent modeling, which I'll cover shortly, solid and feature modeling, assembly modeling. NX is very strong on assembly modeling, drafting, airframe features, mechanical surfacing, sheet metal design, PCB exchange, mechanical and electrical routing. So convergent modeling from Siemens is a game changer. Convergent modeling allows the direct editing of facets, surfaces, and solids. The convergent modeling environment enables designers to directly manipulate facet bodies and combine facet and B-rep geometry. In practice, convergent modeling allows you to work directly with scanned data, eliminating the need to reverse engineer designs. So this allows designers to quickly optimize and prepare parts for 3D printing. Then synchronous technology is another game changer. Synchronous technology allows you to edit your data no matter where it comes from or the current state of your models. You have the ability to make changes on your models that have no history at all, or history-based models that have not taken into account the needed changes. So synchronous technology is also a game changer for engineering analysts and manufacturing users who make dramatic process improvements by working directly on the design geometry. The result is a shorter product development lead times and improved product quality. So I will soon demonstrate some synchronous technology capabilities in the next slide. Model-based definition. There are several acronyms and terms you will hear used surrounding model-based definition. One acronym that many recognize is PMI. PMI stands for Product and Manufacturing Information. PMI is a non-geometric data applied to a 3D model to convey information about the design of a product's components for manufacturing. Model-based definition is commonly referred to as MBD, is the practice of producing a complete digital definition of a product within a 3D model. So MBD focuses on ensuring that a 3D model contains all the information needed to define the product in an annotated and organized manner, thus replacing a traditional drawing. And lastly, model-based enterprises, commonly referred to as MBE, is the process of reusing model-based definition by downstream consumers across enterprises. What we have seen over the past few years is significant numbers of customers moving to adopt a model-based definition strategy. I think it's fair to say that it's not a question of if companies will adopt model-based definition, but rather a question of when. Looking at process integration, in NX, you have the flexibility and versatility to use the best tools and approaches without switching applications or transferring data. Part of process integration is the ability to move engineering data. So Siemens provides three distinct, discrete solutions to address the different reasons you move engineering data. Migration, bringing your data into Siemens from another product. This is a one-time and a one-way move of engineering data. Then with translators, there you've got a bi-directional transfer between NX and design solutions from a different vendor. And then with multicad, this is where NX coexists and collaborate with other systems in real time. And then with process automation and validation, Siemens provide a complete suite of validation tools that encompass every aspect of supporting your quality needs and initiatives. Sorry, okay, so this video shows several modeling, synchronous technology modeling commands. The ability to move a face to lengthen the bracket, so that you can select the face and then you can easily drag it to the length, or you can set the length as you required. And then with a rubber band selection, you can move another entire bracket using synchronous technology. Here's an example of surface modeling. So with XForm, you'll have the ability to morph an analytical boss into a freeform domed feature. And keep in mind, this it doesn't matter in which package you've created this part originally. So using the various tools, you can nicely and quickly edit that boss. Here we are adding a motor and wire assembly to the fan shroud. And what you can see there's a gap between the motor and shroud. So we want to reduce the radial dimension of the shroud. So you just select the face, and then you can select how you want to reduce the radius, in this case by just adding a value. And this is real time, so this is not fast forwarding. And again, you can do the same exercise with the outer shroud. So with the move face option within Synchronous Technology, you are able to relocate hundreds of faces there using, again, the rubber band selection tool. So you'll see it's now selecting all of those faces. You can realize that it takes some time, but it's a lot of faces that you're now selecting. So you're now able to relocate those faces instantaneously to be concentric with a circular feature on the shroud. So they select the circular feature, and it moves it almost instantaneously. So the rework on large scale, such as shown here, could take several days, understanding it and editing parametric modeling features. In only a few minutes, the user is able to perform an extensive redesign of this part. So the time saved reusing these components is immense with synchronous technology. So let's have a look at the pricing options for NX. So unlike other CAD software vendors, Siemens do not force you to choose a certain type of licensing model. You as the customer can choose how to purchase an NX license. So let's briefly look at the different licensing options. A perpetual license is basically a license that the client then owns. Depending on the software, this can become very expensive, and it's assumed that it will be funded through CAPEX, capital expenditure. Even though it's a perpetual license, it is strongly recommended that the maintenance is be bought with it, because the software version might not be supported forever or for a very long time. Even though the purchase of the perpetual license require a lump sum of capital expenditure, with annual maintenance, it still works out cheaper over the long run. Maintenance enhancement and support, also referred to as MES, is normally 20 to 25% of the perpetual license and give you access to technical support and software updates. This is the running cost and is assumed will be funded through operating expenditure. So maintenance is normally annually, but you can purchase up to 3 to 5 years of maintenance. Subscription licenses is a license that is granted to a customer for a limited period of time. So the minimum period is 12 months, but this can be extended to 3 years. The benefit of a 3-year subscription is that you fix the price. Subscription is renewable, but it cannot be converted to a perpetual license. So maintenance, enhancements, and technical support, MES, is included in the price. So this gives customers the flexibility they need to access the software they need in a way that fits with their own business model, not in a way that's forced on them by the vendor. A subscription license is a good short-term option to trial a license within a business setup before committing to a perpetual license. Then hybrid SaaS, hybrid software as a service, is the new subscription-based offering from Siemens. Hybrid SaaS is similar to subscription, but with the service centrally hosted on the cloud and partly run on the customer side. So this allows you to perform part of your work on your company's premises and part of the work in a cloud hosted or managed by Siemens. The hybrid SaaS includes Accelerator Share, which is an engineering-specific project-based ad hoc cloud collaboration tool. So Accelerator Share is independent of Teamcenter, but works alongside it. Think of it as Dropbox for engineers, but with engineering-specific features and capabilities. And Accelerator Share is secure. Then value-based licensing, also referred to as token licensing, provides a very flexible and cost-effective way for small, medium-sized, and many large customers to run almost any NX product engineering add-on module. So with tokens, customers can check in and check out over 70 applications currently in the token pool. As new add-ons are added to the pool, customers will be able to use them without additional effort with their internal purchasing team. So token licensing is both similar and different from a per seat floating license. It's similar to per seat floating licenses in that both have a pool of products from which the user checks out what is needed. Then when the user is done, the product is checked back into the pool and to be accessed by a different user. It's different from per seat floating license in that for per seat floating licenses, the product pool is comprised solely of the products that the company has purchased. Whereas for token licenses, the pool is every product that participates in that token license pool. Thus, a greater set of products can be accessed. But let's have a look at how NX functions within the additive manufacturing environment. Engineering is using additive manufacturing to overcome some of the limitations associated with conventional manufacturing. However, even within the additive manufacturing domain, there are challenges with product development. So we all know that new technology comes with hurdles and roadblocks to overcome. Design for additive manufacturing is one example where product development requires a rethink. To leverage the capabilities of additive manufacturing, you need an end-to-end digital solution thread. In the case of additive manufacturing, there are independent applications that don't work together, file formats that need to be merged, etc. In a typical additive manufacturing process flow, each step uses a different software application that requires the model to be converted into a different file format. Usually STL files is still common. This, however, causes information to be lost and takes up extra valuable time. Imagine how time-consuming it would be to try to make and manage frequent design changes in this environment. This disconnected process chain, multiple file conversions and tools, and an uncontrolled workflow negatively impact productivity and revenue potential. So NX Design for Additive Manufacturing provides a single integrated environment and workflow from requirements-driven generative design to 3D printing. NX offers a set of additive tools that integrates product design, simulation, and 3D printing preparation. These tools allow the following benefits. In design, bionic, lightweight, and functional structures can be created. Convergent modeling allows the direct use of optimized designs. Validation that designs are suitable for additive manufacturing with checkers and Simcenter build process simulation. It speeds up end-to-end workflow productivity through seamless design, simulation, and manufacturing collaboration. Management of data and processes with full traceability. To connect the entire operation, the manufacturing data is managed with Teamcenter, the Siemens PLM software collaboration platform. The Siemens production software Camstar helps you optimize manufacturing operations performance. It lets you digitalize and seamlessly integrate product and production life cycles for flexible, scalable production processes. And Siemens have partnered with additive manufacturing industry leaders to deliver complete solutions to the 3D printing technologies. Now let's take a closer look at the design solution for additive manufacturing, specifically at Convergent Modeling. So designers and engineers can take advantage of generative design, where the computer assists in design by iterating on calculations to create complex, optimized, and organic shapes that achieve designer input performance goals such as strength and weight. So designers can leverage convergent modeling to scan physical models and then modify digital designs for 3D printing. Assisting in the form of rules and checks guide designers to ensure designs can be properly printed. So engineers can leverage convergent modeling that greatly simplifies working with geometry consisting of facets, surfaces, and solids. This generative design method helps engineers optimize part design for 3D printing and speed up the overall process. Convergent modeling helps you eliminate the error-prone and costly process of rework while supporting new manufacturing techniques for complex and irregular shapes such as 3D printing. So the value of convergent modeling is the ability to reduce development time significantly and improve design quality. What Siemens found is that there are many workflows in additive manufacturing that require the use of facet geometry. For example, in the normal workflow, you run a part through topology optimization, and you're given a blob of facets that you then have to turn back into a usable part. But with convergent modeling, this process is easier than ever before because the same modeling techniques and features you use to create native CAD geometry can now be used on facet geometry. And in many cases, you can completely remove the rework stage and use the output from the topology optimization directly in your NX model. So other capabilities within NX that are not covered here today are topology optimization, lightweighting with lattice designs, additive design rules, and checking uh, algorithmic patterning. But let's have a look at the demonstration of convergent modeling. So this is NX modeling with the faceted model that has been optimized for weight and strength. You can adapt it for more strength and using precise modeling tools. So facet geometry is playing an increasingly important role in the design to manufacture workflow. For example, with generative design, reverse engineering, MRI and CT scans, and the simulation-based facet tools. Traditional CAD tools can't do precise design on facet models like this one. This means that even if you know exactly what design changes need to be made, you can't make it on the same model. You need to completely remodel the part in order to improve a feature or reshape a surface to hit a new target, or prepare the model to be made at an alternative manufacturing location. This slows down innovation. So you can use the precise modeling tools in NX to add material directly to this faceted model to strengthen the arm of the bell crank and prepare it for manufacturing. So with subdivision modeling to manipulate this model like putty or Play-Doh, that is the ability to create freeform and organic shapes, you can then strengthen the part as needed. So to conclude this demonstration, Siemens PLM software system provides solutions for additive manufacturing by using a smart model-driven process. The fully integrated system for additive manufacturing, including NX, SimCenter, and Teamcenter software, can enable you to support the entire additive manufacturing process. You only use one part model for CAD, CAE, additive manufacturing, CAM, using one software technology. It's easy to incorporate design changes using associative part models, and there is full PLM integration. So I want to conclude with the following recommendation from the Life Cycle Insights report on digital twins for 2022. Companies should define a strategic plan to develop and manage their product design and production engineering digital definitions using standardized tools and technologies. So companies should consider how a comprehensive digital twin and unambiguous definition of the product and digital threads, the digital processes used to execute development, can be enhanced over time by various digital transformation initiative investments. At the same time, integrations between the digital twin and digital threads are necessary to avoid errors and accelerate product development. So companies should identify their position in the maturity map based on the findings in the report I refer to in both product design and production engineering. Then they should implement strategies to bridge gaps on the maturity scale. For more detailed information on specific design, simulation, or product lifecycle management capabilities, please do not hesitate to contact myself or my colleague Hannu Stein at the email address shown on the slide. And remember to follow us on LinkedIn. And just a friendly reminder, the next webinar on simulation, SimCenter, will be held on Thursday, the 19th of May. Same time, same place. Thank you very much. It's now time for any questions and answers. And we'll be opening the floor for questions. Oh no, I just want to check if we've enabled.
I am enabling it now. It is enabled.
So I've shown NX within the additive manufacturing environment, but this was just one example. Of course, the same features, capabilities, and advantages that NX brings to additive manufacturing are able with in almost any domain of product development, be it within the mechanical or electrical domain. Just note that I've said electrical, not electronic. Okay, if there are no questions, okay, well, this question from Elvin. Can we unmute him?
He should be unmuted.
Can you hear me?
Yes, we can hear you.
Yes. Hi, Marius. Thanks for the presentation. You noticed, or you mentioned in this webinar and in previous ones that top-down support is important. If you want to do an implementation like this, are there return on investment sort of models that a person can prepare to support implementing a PLM system? Have you guys looked at something like that? Or if an organization approaches you, then would you be able to support them in making those strategic decisions based on where they want to go? Or is that just a process that needs to happen? And more or less, what's the time spent for that?
So I'll quickly try to answer your question, and Hannu, please fill in where I miss anything. So return of investment questions are always difficult to answer, but there are some generic models that we have for different engineering solutions, for example, for PLM as well as for CAD. But it depends on where your starting point is, because most of that return on investment models assume that you are still using a 2D CAD based system. And when you then move to, let's say, a 3D CAD system like NX, then there will be significant return on investment. For PLM, one of the quickest calculations for me to show the return on investment, and this is a statistics that come out of the global north, mainly the Americas and Europe, where they say that an engineer spends about 25% of his or her time on non-value adding processes like looking or searching for information. And so 25% is a lot of time. That's 1 day a week. That's more than a month a year. I think it's more than 2 months a year. So you can quickly calculate, well, how much time does that, what is the cost of an engineer? What is the salary of an engineer? What is the cost of company of an engineer? And take 25% of that. That's time wasted on trying to find information because you don't have a proper PLM system, because you don't have an integrated comprehensive solution. But that's just a very quick way to look at it. There, with the new cloud-based solutions like Teams NX and NXX, you can then start looking at return on investment because, yes, you are paying more for that service, but you don't need to suddenly buy expensive computers for using cloud-based solutions. For example, with NXX or with CAD systems, like NX, you normally have minimum requirements for your workstation. But for the cloud-based version of NX, you don't. You can use your normal laptop for that. So that makes IT management a lot easier. The same with PLM or Teamcenter hosted on the cloud and managed by Siemens. That reduces a lot of your costs for setting up the database and servers to host that PLM. And then just so I know, just one last example. One of the reasons why I chose additive manufacturing was internally, I introduced NX for additive manufacturing. And one of my engineers who used to work on Inventor, and he quite liked Inventor, which is a competitive product. And he was amazed by the level of integration from start to finish in NX within for additive manufacturing. He was used that within because Inventor did not have that full integration. He had to export a lot of data and import it into other software. So there was a lot of, as he put it, dumb model migration. Whereas with NX, when he got to the build preparation part and he saw an error, he can quickly go back to the design, make those changes, and those changes were made throughout the whole additive manufacturing process. So that saving time on that alone is a lot of saving on return on investment. So Hanu.
No, I just want to agree with you, Morris, especially at the beginning, but and Elron to just get onto that. I think we've all been in a situation where we are looking, I mean, to sort of return on investment, and I mean, you can really go into big detail in terms of how much faster am I now working and compared to other stuff. But I think that one point in just in terms of looking for data, how much time do I spend looking for that one thing that is not my day-to-day project? I need information. So it's my time I'm wasting, and then usually what we do is we email or we call, and we waste 3 or 4 other people's time as well. So and as soon as you start to do that, and you say, well, I'm looking for data at least 3-4 times a week, and it might not be a full day, but every half day a year, it adds up. And if you then go and you say, okay, well, if now I think at least you guys are using NX, so you've got this advantage of using a CAD package that can really speed up. I mean, if you come from any other package. You sort of, once you work with NX, you get this feel of increase in speed, how quick a thing can be, and especially with synchronous technology, where you could take a CAD data from any other package and just drill a hole, move a hole, and not really have to think about the history on how did you get to the hole. So if I move the hole, what else do I break? And as soon as you get, well, if I move this hole, what do I break? Then again, you're on the phone calling somebody, say, listen, you created the model, what now, how now? And again, it's all of this little stuff that sort of slows you down. Yeah, sorry, that's.
But,
thank you.
oh,
That's awesome.
On what we can do is we can have a discussion offline and look at some of those return on investment models, and then see, because like I said, yes, it's generic models, but they are including a lot of information there that we sometimes do not even consider when looking at return on investment, because like you've said, when managers or decision makers look at a request for a purchase, they're not necessarily looking at the technical features or capabilities of that product. They want to know how much does it cost, and is it really worth that cost or that price. So what I can do is we can have I can contact you, and then we can have a look through some of those ROI calculators.
Yeah, that'll be great. Thanks, Marius. I was just wondering for interest sake. Yeah, I've had to answer questions like that in the past, and I didn't know where to start.
Yes,
So, yeah.
I know the feeling, and it doesn't get better, but the more you read into it, the better you hopefully can answer those questions.
Okay, thanks, guys.
Any other questions?
Not from me, sir.
Okay, so on that, I thank you very much for joining us today, and looking forward to see you at the next webinar.